Alright, this is the seventh and final part of our lesson on graphing rational functions. Alright, so let's take a look at number 8 and talk about vertical asymptotes, horizontal asymptotes, slant asymptotes, holes, domain, and continuity. Alright, first let's talk about horizontal asymptotes. For horizontal asymptotes, you look at the degree of the numerator and the denominator. That tells you what situation you're in. If the degree of the numerator is less than the denominator, then there will be a horizontal asymptote at 0, at y equals 0. Okay, so that's the case here. That means there will be no slant asymptote. Alright, slant asymptotes happen when the top degree is 1 higher than the bottom degree. So no slant asymptote. Now let's talk about vertical asymptotes and holes. Now normally for the vertical asymptote we simply look at the denominator, set this equal to 0, but first you want to cancel out anything that needs to be canceled out. And when you're canceling factors out, you're talking about holes now. So look, we have a lot of stuff to cancel out here. You can think of this as we have x to the 17th power, right? But you can think of x to the 19th power as x to the 17th power times x squared. Alright, I'm just pulling two of those x's off to the side. So x to the 17th power will cancel out. So that would leave you with 1 over x squared. Alright? So if I set this x squared equal to 0, take the square root of both sides, that's going to give me x equals 0. So I will definitely have a vertical asymptote of x equals 0. Now normally I would go, alright, now the one that canceled out, that's going to give me a hole, right? And I would go, let me change colors real quick. I would say, what about setting x to the 17th power equal to 0? And, I would technically take the 17th root of both sides, and that would give me x equals 0 as well. And, but whereas this was a vertical asymptote, when things are canceling out, I'm wanting to call that a hole. Okay? But you can't really have a hole at the same place where you already have a vertical asymptote. It can't be both. And remember, a vertical asymptote is a place where you will have no points at all. And a hole is a place where there's no point there. But you really call it a hole when the graph is going along, minding its normal business, and then you have one missing point, and then it goes on from there. Okay, if you already have a vertical asymptote, so you don't have any points there at all, and the graph never, just never gets there, then it doesn't make any sense to have a hole on a vertical asymptote. Okay, put another way, when we go to graph a hole, you know how we'll say, okay, the x value of the hole is 0. How will we find the y value of the hole? Well, normally we would put the rest of the function that didn't cancel out in our calculator, and we'd look for the y value. But what's going to happen when we look for the y value now? That's not what I wanted. If I tried to look for this y value, and I'm hoping in your head you kind of know what I'm going to see here. If I do 1 over x squared, and I want to see what's happening at 0, guess what? Error. Of course there's going to be an error. So I still can't find out the y value. That's because it's still undefined. Okay, we still can't have 0 here. That would still be a 0 denominator. So there, you can't call this a hole, even though it canceled out. It's already a vertical asymptote, so you can't have a hole where you have a vertical asymptote. You can't have a hole at a place that's it's already undefined. Even if you cancel out the hole, it's still undefined. So So there's no hole, it's just a vertical asymptote. So the moral of the story is, if you have a vertical asymptote and a hole at the same place, the vertical asymptote wins. Okay, just call it a vertical asymptote, not a hole. So, let's go ahead and graph these two asymptotes. So I have a vertical asymptote at 0 and a horizontal asymptote at 0. There are the asymptotes. Let's look in the graph. Let's look in the calculator and plot some points. So I already have the equation in the calculator. You know, I'm using the version after I canceled stuff out, but it really wouldn't have made a difference either way. Okay, let's start off at, let's say, -2, for example. Alright, at -2, I'm at 1/4. So -2, I'm just a little bit above the line. At -1, I'm at +1. Okay, I'm going to come back for this decimal in a minute. Alright, but for right now, okay, there's our asymptote. At 1, we're at 1. At 2, we're at 1/4, which is just a little bit up. Wait, so is this all positive? That's really interesting. Okay, yep, everything's positive. Just want to make sure I'm not missing it. Okay, now I want the decimals. Whoa, I got off track here. I always like to know what's happening really close to the asymptote. So a little to the left, that's -0.5. A little to the right, that's +0.5. Okay, so to do that, I think I'll just use ask mode instead of auto. So if I do ask mode, oh look, -0.5 and +0.5, they're already in there, but you can type in whatever you want. At -0.5 and +0.5, I'm at 4. Okay, so let's graph that. So at -0.5, I'm at 4, and at +0.5, I'm at 4. Okay, so this is a very interesting graph. We don't see these very often. Normally you have a branch up here and then a branch down here maybe, but this time they're both up. Okay, so that is going to give me like this. Alright, that got a little crazy there at the end. Well, what are you going to do? Okay, so your graph should look something like this. Now the domain is going to be -infinity to 0 and then 0 to +infinity. Okay, -infinity to 0, union 0 to +infinity. Now is this graph continuous or discontinuous? Well, continuous means it would be unbroken. Alright, it's clearly split into these two branches, so this is discontinuous. Okay, now the discontinuities are these two asymptotes, and they are both considered to be non-removable. Okay, asymptotes are non-removable discontinuities. Okay, a removable discontinuity would be a hole. Okay, a point discontinuity. But we didn't have any of those, so we just have this. And that is it. We finally finished. We finally finished, you guys. So that's the end of this lesson. Hope it was helpful to you, all 7 parts of it. And I will see you on the next video.